just when the entire EV world had settled into the belief that rare earth metals were unavoidable. Something happened that quietly shattered that assumption. A single announcement sent ripples through the auto industry, forcing engineers, investors, and competitors to pause and reassess everything they thought they knew. Tesla revealed that it was working on an electric motor that doesn't rely on rare earth metals at all. No neodymium. None of the materials the industry had treated as essential for decades. And that immediately raised an uncomfortable question. If this really works, why did everyone else believe these metals were necessary in the first place? And more importantly, what happens to the global EV power balance if they're no longer needed? For years, electric vehicles have been marketed as clean, futuristic machines. Quiet, efficient, and environmentally friendly on the surface. But behind that image was a dependency few consumers ever thought about. Almost every modern EV motor relied on rare earth metals to function at high efficiency. These materials made motors smaller, lighter, and more powerful, but they came with serious downsides. They're difficult to extract, environmentally destructive to mine, and found in limited quantities. Over time, what started as a technical advantage slowly became the industry's biggest vulnerability. The real issue wasn't just scarcity, it was control. The global supply of rare earth metals became heavily concentrated in a single region. That meant car makers across the world were building independent electric vehicles that secretly depended on the same fragile supply chain. Prices fluctuated wildly, long-term planning became risky, and despite government pressure to make EVs affordable for the average person, the cost of one critical component kept rising. The future of clean transportation was quietly tied to materials that were neither clean nor secure. This was the reality most automakers accepted. Rare earths were expensive, but they worked. So the industry kept moving forward, improving batteries, software, and charging speeds, while the motor itself remained largely untouched. No one seriously questioned the foundation. Until Tesla did. Instead of asking how to secure more rare earth metals, Tesla asked something far more disruptive. Do we actually need them at all? That question alone was enough to unsettle the industry. Because if the answer turned out to be no, it wouldn't just be an engineering breakthrough. It would be a strategic earthquake. To understand why this matters, it helps to simplify how electric motors work. At their core, motors rely on the interaction between electricity and magnetism. Electricity flowing through coils creates magnetic fields, and those fields produce rotation. Traditionally, powerful permanent magnets made from rare earth metals were used to strengthen this process. Stronger magnets meant more torque in a smaller package, simple, effective, and extremely expensive. The downside was efficiency control. These magnets operate at full strength, whether the motor needs that power or not. That means wasted energy, excess heat, and gradual performance loss over time. As motors worked harder, temperatures climbed, and heat, more than anything, is what silently degrades electric systems. Tesla approached the problem from a different angle. Instead of relying on brute magnetic force, it focused on control. The idea wasn't to remove magnets entirely, but to reduce their importance. Power wouldn't come from stronger materials, but from smarter timing. By precisely controlling how and when magnetic fields are generated, the motor can deliver power only when it's actually needed. No constant strain, no unnecessary force. Think of it like this. Instead of flooring the accelerator at all times, the motor learns exactly how much push is required in each moment. City driving, cruising, overtaking, climbing, each scenario gets a tailored response. The result is less wasted energy, less heat, and more consistent performance. This change has a cascading effect. With reduced heat generation, cooling systems don't have to work as hard. That means less weight, fewer components, and lower long-term wear. A lighter motor improves efficiency across the entire vehicle. The battery doesn't change, but suddenly it feels like it lasts longer. Not because it's bigger, but because the motor is wasting less of what it's given. Performance is where this shift becomes impossible to ignore. Traditionally, higher performance meant higher energy loss. Push the motor harder, and heat would spike. Power would fade during sustained high-speed driving. Tesla's new approach flips that relationship. Power delivery becomes smoother and more consistent. Acceleration feels linear, not aggressive. There are no sudden surges, no drop-offs. just steady force, exactly when it's required. That smoothness isn't just about comfort, it directly affects longevity. When systems aren't constantly stressed, they last longer. Motors don't fatigue. Components don't degrade as quickly. Years down the line, the vehicle feels closer to how it did when it was new. That's a quiet benefit most buyers don't think about, but one that matters deeply over time. For everyday drivers, the impact is immediate. Range anxiety begins to fade. The car simply goes farther on the same charge. Charging stops become less frequent. Planning long trips stops feeling like a calculation exercise. The experience starts to resemble what people are used to with petrol cars. Get in, drive, don't overthink it. Cost is where the long-term consequences really start to show. Rare earth metals are one of the reasons EV prices have struggled to fall as quickly as many hoped. Remove them from the motor, and manufacturing becomes cheaper and more predictable. Supply chains stabilize, price volatility drops. Over time, those savings can be passed to the consumer. EVs stop feeling like premium experiments and start looking like practical choices. But this shift doesn't exist in isolation. It directly affects global competition. For years, China's dominance in rare earth supply gave its EV manufacturers a structural advantage. Companies like BYD built massive vertically integrated systems that leveraged access to raw materials. That advantage helped them scale quickly and aggressively. Now, that foundation is being questioned. If rare earth metals are no longer essential, the balance of power begins to shift. Countries and companies that once feared supply disruptions gained independence. Manufacturing becomes more localized. Strategic reliance decreases. This isn't just about cars anymore. It's about control. That's why this announcement has geopolitical weight. It opens the door for the US, Europe, and other regions to strengthen their EV industries without depending on a single supply source. It reduces vulnerability. It changes negotiation dynamics. And it forces competitors to rethink their long-term strategies. From a market perspective, the effects compound. Lower motor costs mean lower vehicle prices. Lower prices accelerate adoption. More adoption expands charging infrastructure. Investment flows increase. New players enter the space. EVs stop being niche and start becoming the default. This also puts pressure on legacy automakers. Incremental updates won't be enough. Simply swapping batteries or tweaking designs won't compete with a fundamentally different motor architecture. To keep up, companies will need to rethink how their vehicles are built from the ground up. That's expensive, risky, and time-consuming. This is where Elon Musk's philosophy becomes clear. Instead of improving what's expensive, he prefers to eliminate it entirely. Fuel dependence, dealerships, physical keys, and now, rare earth metals. Each time, the goal isn't just innovation, but freedom from future constraints. So what's the real motive here? Is it environmental responsibility or strategic dominance? The honest answer is both. Removing rare earth metals reduces mining damage and cleans up the supply chain. At the same time, it gives Tesla a powerful competitive edge. The company that removes tomorrow's bottlenecks today controls the pace of the industry tomorrow. Looking ahead, the EV landscape won't look the same. In 5 to 10 years, the debate won't be whether electric cars make sense. It will be which one offers the best balance of cost, range, and reliability. Charging stations will be common, prices will stabilize, and the technology that once felt risky will feel normal. The motor may not be the most visible part of a car, but it's the heart of everything. And when the heart changes, the entire system follows. What Tesla has done isn't just refine an idea, it has challenged an assumption the industry never questioned. And once an assumption breaks, there's no going back. The only question left is how fast the rest of the world can adapt. What happens next is where the story becomes even more unsettling for the rest of the industry. Because once a breakthrough like this proves viable, it doesn't stay exclusive for long. Engineers across the world start dissecting it. Automakers begin quietly adjusting their roadmaps. Suppliers feel the shift before the public ever does. And suddenly, what once felt impossible starts becoming the new benchmark. This is how industry standards change, not through loud announcements, but through silent pressure. One of the biggest long-term consequences of this motor is how it reframes innovation itself. For years, progress in EVs followed a predictable path: better batteries, faster charging, more software features. Motors were treated as good enough, something to optimize slightly but never reinvent. That mindset is now outdated. If the motor can be redesigned to eliminate cost, reduce risk, and improve performance at the same time, then every other assumption is back on the table to dot this